All right, now we get to start on something completely different. I guess it's not completely. We've dealt with triangles before, but we're going to be looking at trigonometry. This first section we'll look at trig ratios and how we can use our calculator with them. And after that, we'll get into more trig ratios, more understanding of the triangles, and some other tools we can use to solve triangles that aren't right angles. Anyway, so here we're going to solve a trig ratio for an angle. We'll also solve one for a side. And then uh, uh, we'll look at the interplay between ratio of sides and angles. To begin with, what are some things that hopefully you know about right triangles so far? Some of you may have had a little bit of trigonometry experience in the past, but here's some things that you may know already. If I have a right triangle, I have a relationship that I know from Pythagoras that says this. If I take the longest side, that's C, here's side C, and if I square that, it's equal to the sum of the other two sides when they've been squared. Okay, so if I have this triangle and I've labeled it like this, so C squared is equal to A squared plus B squared. That's a relationship that's nice to know about right triangles. It doesn't apply if they're not a right triangle. There's other two, we can modify this a little bit, but if I don't have a right triangle, I can't use this one specifically. Now notice how I've labeled the sides. It's also nice to label the angles of a right triangle. To label the angles, you always label the one that is across from it. So if this is side C, then angle C has to be, oh, that's B. Well, I'll do B. B's here, so angle B has to be across from it. So side C is there, angle C must be there. Side A, Side A is there, angle A must be over here. Now, some other things you might have heard before are the ideas of a side opposite or a hypotenuse or a side adjacent. These ones, I guess the hypotenuse is always the longest side. So we typically refer to it as C, but we can call it any letter we want, but it's the one that's opposite the right angle. And it's always the longest side. Now, to determine which side is opposite and which side is adjacent, I first need to fix an angle. And this is what my theta is here for. If I fix this to be the angle that I'm going to be working with, and I typically do a cute little line like that to indicate that's my angle I'm working with, then I can now identify the side opposite and the side adjacent. The side adjacent is the one right beside that one, right beside the angle in question. That isn't the hypotenuse. Hypotenuse is already called, so this must be the side adjacent. Leaving that other side way over there, let me turn that a little bit, this side over here to be my side opposite. Okay, so that's labeling a right triangle. Knowing the hypotenuse, adjacent, and opposite sides is critical when we're looking at trigonometry. The last nice thing to know about a triangle is that the measure of all of the angles in any triangle, and including a right triangle, always add up to 180 degrees. We'll need to know that a little bit as we go through some questions. All right, let's look at now the ratios that I form when I'm looking at the angles of a right triangle. If I have a right triangle and say my angle in question is this one there, I can look at ratios between sides. Now just take a look at this for a second. I didn't really draw it. Well, I'll do it this way. Whoops, let me get a pen. Okay, so take a look at this angle here. It looks to be about, I don't know, a 30-degree. Watch what happens to the side when I take that angle and make it bigger. So say a 45, maybe a 45-degree angle. Sorry, I'm going up a little bit high there. But notice I've changed this angle from being around 30-ish to around 45 or 50-ish. But take a look at what happened to the length of this side here. See, this side has now gotten a whole lot bigger than this side. And that's what these sine, cos, and tan are referring to. And they've just, there's some tables or there's some ratios that we've put together that tell us that if I increase, or if this angle is increased, this side is going to increase. If this angle is decreased, like if I make that quite skinny, an angle like 10 degrees or something, then this side here is decreased a whole lot. And that's what all of these ratios are based upon, is they're based on the ratio of the sides in that right triangle. And we just figure out, okay, there has to be a ratio between this side and this side, and this side and this side, and this side and this side. And we've just called them a name. I wish they'd have called them Jeff. It would have been nice to have a trigonometric ratio called Jeff, don't you think? Okay, a little silly. Okay, anyway, the sine ratio, this one, refers to the relationship between the opposite side, that's this one, and the hypotenuse, that's this one. Okay, so the sine ratio, it helps me look at what happens to this side and this side based on my angle. Okay, the cosine ratio, it relates the adjacent side to the hypotenuse. And lastly, the tangent ratio relates the opposite side to the adjacent. We also have reciprocal ratios where these things are flipped over, but I'm not going to worry about those just yet. Okay, so here, these things here, sine of an angle, that's my angle, is equal to the opposite side over the hypotenuse. These are actual formulas that I can use. And like any other formula, if I know two of the variables, I can figure out the third one. If I know these two sides, I could figure out what the angle was. If I know this angle and I know this side, I could figure out what the opposite side was. So it's just like any other formula. Now it's important that you memorize those names so that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. This little thing up here is something that a lot of people use to memorize it, the SOH-CAH-TOA, sine, opposite hypotenuse, cos, adjacent hypotenuse, tangent, opposite over adjacent. So if that helps you memorize them, go ahead and use that. Let's try these in action. Here I've got a triangle. And what I'm looking for is I want to know what this angle is right there. I want to know what that angle A is. I know I have one side is 8 and I have another side that's 6. But I want to know what this angle is. Well, in order to do this, what I want to do is I want to determine which of these three ratios I need to use. When I look at this, if this is my angle, the longest side is always my hypotenuse, and this side that's right beside my angle is always the adjacent side. This is the opposite side, but in this question, I don't need to do that. I'm always looking at two sides and one angle. So now I just have to look at which of these ratios over here have an adjacent and a hypotenuse in them. And it looks like the cosine ratio has those. So what I do is I write down my formula. Cosine of an angle is equal to the adjacent side over the hypotenuse side. And now I'll plug in everything that I know. So I'll go cos. The angle in question is actually labeled A, so I'll put an A there, is equal to the adjacent side is a 6 and the hypotenuse side is an 8. Now I just need to solve this equation. Now when solving the equation, when I'm solving this equation, I have a little bit different kind of function here that I haven't seen before. And the way I deal with that is this. What I want in the end is I want to know what A is equal to. I want A is something. So what I have to do is I have to get rid of this cosine off of this side. Now I can't just divide by a cos because it's a different kind of function. But there is a way of getting rid of a cosine. And the trick to get rid of that is to do the arc cos, or some people call it the inverse cos. I don't like to call it that. Some people call it cos to the -1. Look on your calculators though and find the cos button, and then you'll find right above the cosine, you'll find a button that says cos -1. Some calculators say arc cos, but most of them say cos -1. And that's what we do. I'm going to do this little thing because it helps me to get rid of this cos, but typically you wouldn't see this in a book. What I do is I say, to get rid of this cos, I have to take the arc cos. Sorry, I'm going to write it the way you've got it in your on your calculator. So I'm going to say, I'm going to take the arc cos of, well, I'm going to take the arc cos on both sides. And on this side I have a cos A, and on this side I have a 6/8. So I take the arc cos of this side, I take the arc cos of that side. What I do to one side, I do to the other side. But this arc cos and this cos, they cancel each other out. So leaving me with, on this side, just an A is equal to. And now I take out my trusty calculator. Let me get mine. And I'm going to take the arc cos, if I can find my arc cos. It's that one. Hopefully it's this one, arc cos. No, that's not it. Arc cos. Yeah, there it is. Arc cos of 6/8. Make sure you put that 6/8 in brackets, just so you don't mess that up. Equals, and I come out to, just a second. I'm almost coming out to something. My calculator's a little funny. 41.4. Is that what you got? Hopefully it is. So the angle is 41.4 degrees. So this angle right there, 41.4 degrees. Now, knowing that this one's 41.4 and this one's 90, knowing that they all add up to 180, I could also figure that angle. Okay, maybe turn your attention to your textbook and try some questions. When you're ready for the next part, hit play and we'll look at finding sides. Okay, solving for a side. Notice that all the time when I'm dealing with these basic trig identities, all I need are two pieces of information and I find out a third. So in this question they say, I want to solve for a side. Let's pick, I don't know, let's pick this side. So this side is letter A. Okay, so my question is, I have an angle of 38 degrees, I have a side of 15, I want to figure out this side over here. So my first step, mark my angle, done that already. Determine which ratio I have. If this is my angle, then this side over here is the opposite side, and this side here is the longest side, that's always my hypotenuse. So I need to find a trig ratio that has an opposite and a hypotenuse in it. That's my guy right there. Let's write it down. Sine of an angle is equal to the opposite side divided by the hypotenuse. Okay, let's plug numbers in. Sine, I know the angle, so sine is 38, is equal to the opposite side, I don't know, but I know it's called A, over the hypotenuse, which is 15. All right, now I need to solve this equation. Notice that this one's different because I know what the angle is. So if I know what the angle is, I don't need to do an arc sine or arc cos kind of thing with it. I know what the angle is, I just have to type that out, which we'll do in a second. But I need to solve for A, got to get rid of this 15, so I'll multiply 15 on both sides. So I'll come up with 15 sine 38 degrees is equal to A. Now, plug that in your machine. Let me try mine, see if mine will work for me. 15 sine 38. Uh-oh. My calculator went funny. Okay, I'm back. 15 sine 38 equals, oh, I'm always forgetting that, the bracket, 9.23. So my A, oops, sorry about that. Seeing a list of my files there. Here we go. My A comes out to being 9.23. So this side up here is 9.23. Again, just if I wanted to solve that whole triangle, notice that I could, this is 38, this is 90, I could figure out what that angle was. I also know two of the sides. I could use Pythagoras to find out the third side. Right now we're not doing all of that, we're just solving for one thing. Okay, so that's how I can solve for a side of a right triangle. So when you're doing solving questions, if you know what the angle is, like down here, all you do is you type cos 75 and that'll come out to a number. So you just type that out on your calculator, cos 75. If you have a question where you're trying to find the angle, you don't know the angle, like a question like this, cos theta is equal to 0.5, then I'm going to have to get rid of that cos. And remember, our trick for that was to find the arc cos of each side. And so if you do the arc cos of 0.5, I think that comes out to 60 degrees exactly. Okay, so if I know the angle, I just hit cos in the angle. That'll give me what the ratio of the two sides is. If I don't know the angle, I'm going to have to use that arc cos or arc sine or arc, whichever ratio you have, in order to figure out what that angle is. All right, lots of practice. I would spend some good time with these ones, going through lots of questions. And if you have any troubles, replay the video or give your instructor a call.